As I said, today we are on integration, still under the calculus. We are on integration. Okay. So what is the integration about? Integration is simply the reverse of differentiation. Okay. So if I have differentiated a particular expression, then the question is, what did you differentiate before you get that? So that's the bottom line. So if I say differential dy dx equal to so and so, then what did you differentiate before you get that? It's a reverse process, okay? Okay, just like you are walking to Nkoko, okay? Then walking to Nkoko back, you are what? You are integrating. So you either differentiate. Differentiate means you what? You try to separate it, you differentiate it, and integrate it to bring it together. I hope you're getting the point. Integrate means bring something together. Differentiate means what? You separate. So it's as simple as that. So opposite of separating is what? Is to opposite of separating is what? To bring together. Now, so we are talking about integration and the calculus. So it's straightforward. So as I have already told the board, normally at once, we go straight to the point when we begin to solve, because a lot of students, they don't want y plus pi, blah, blah, then we'll be talking plenty without, we are solving problems. You see, finally, it is problem that you'll be solving. And in the process of delivering this, then we give you the guide, what happens, and all the things. So it is through the question, we teach you, that's all. You'll not be waiting and be talking. Sometimes somebody will be talking about theory before you realize the person even gets out of it and why defy whatever. We are going straight to the point. So he said that if dy dx is equal to 4x, find what? Find y. This is it. So how do you find y? Okay. That is all. So over here, what happens is that, look at what I'm going to do. But before then, let me say that if I have let's say n, let's say, okay, y is equal to what do you call? If I want to integrate this, it's going to be what? You are going to write n plus 1. Watch here. Okay? Instead of differentiation, we manual here with plus. And in differentiation, we multiply, here we divide. N plus 1, big. So for example, if I'm having, let's do this as a typical example. Here is to the power 1. So here, what are we going to have? If you want to differentiate this, what are we going to have? It's going to be what? If you want to differentiate this, the differential of this is going to be what? Remember here as well, so we have what? 4 already to the power, so plus 1. Whatever power here, 1 plus 1 again, this thing, then plus c. So here we are going to have 4x squared over 2 plus c. Oh, I guess you are following the point I'm making. It's very simple. We shall be solving varieties and you get it. Don't worry. So this cancels that. So in effect, we are going to have what? Our y is going to be what? It's going to be what? It's going to be 2x squared plus c. That's all. Okay. Let's look at another one. Where c is what? Constant. If I have dy dx is equal to 7x to the power 5. Then how do you find y? I mean, when we integrate it, it's going to be what? 7x 5 plus 1. Then you bring this 5 plus 1 down. 5 plus 1. Then plus c, which is a constant. So here, I'm going to have what? 7x 6 all over 6 plus c. That is, when you integrate it, that's what you're going to get. Okay. Now let's look at another one. if I have, I'm picking them. If they ask us to integrate this is the sign of integration. 3dx. So what happens is that first, let me categorically say this so that you don't get confused. Okay. It seems I jumped a step. If I have dy dx is equal to, let me repeat this one so that you don't get 4x to the power 1. Okay, there are a lot of places, so let me. So over here, this ds will cross and it becomes dy is equal to what? 4x. 4x what? dx. This is what is happening. Okay. So if I'm to integrate both sides, let me put it this way in this person so that you don't get confused. This is y is equal to what? 4x, as I said, x squared over 2 plus c, which is 2x squared plus c. Okay. So over here, that is how it goes. Now let's see another one quickly. If I have, if they ask me to evaluate this 3dx, okay. If the moment you see this sign, it means you are supposed to what? To integrate. So what is going to happen? Remember that this is the same as 3x raised to power 0. Any number raised to power 0 is 1. So the fact that you don't see x here, there is an x raised to power 0 there. Okay, the x. Now I'm telling you why when you integrate you get x to the power. So when you write this is the same as the moment you see a constant, there is x raised to power 0 there. Okay, so here it becomes 3 x raised to power 0 plus 1 all over 0 plus 1 plus c. So in effect, this one is x raised to power 1. So it becomes 3x plus c. I guess I've made my point. Now, we are moving on and on and on. Okay, let's come to this side. So, let me. So if I ask you to evaluate this, that is 8x3 plus 5x minus 1, or minus, let's say, 3. The x, this is the form, this is how it goes. So over here, if you are integrating this, you are going to have 8x4, you add 1 to this, then over 4, plus 5x, yes, or so what? Plus 1, also over what? 2, because of this, then minus, anytime you are integrating a constant in respect to this, here is going to give you what? 3x, then plus c, where c is the integrating constant. So this one cancel the right what? 2x4 plus 5 over 2x squared minus 3x plus c. This is what you are supposed to get. Exactly. So that is that. Now,
Action.
yeah, so let me write the C well, okay? Let me write the C well, otherwise somebody will think. So let me write the C well. So where C is what? Integration constant. So it appeared a little bit. So that is what? The C. Okay? That's it. Okay. Now, let's look at this one also. Let's just get the examples. When you get examples, I think it will be clearer for you. Okay. Now let us evaluate this. Let's evaluate this. X squared minus 3x dx. This one will be what? Will be s. This one will be plus 1. So also over 3 here. Minus 3x. Already there's 1 here. So plus 1 is 2. Over 2, okay, then plus c. So that's it, okay. Now, we can move on and on and on. Now, we want to look at integration in a different. Let's move a little bit deeper. Okay, let's move a bit deeper. It's just like we have the function of function when we were dealing with the differentiation. So let's see this one. We want to see integration in a special form. Integration in a special form. In a form ax plus bn. Let's see how that one also goes. So I want us to evaluate, I have one here, 2 plus 5x to the power 3 dx. We are supposed to integrate this. Now, how are we going to integrate this? We are supposed to integrate this. How do you integrate this? We said that this one, it is more or less function of functions, okay? So we say we let u be equal to what? 2x, 2 plus 5x. I guess I've made my point. So if that's the case, then du dx, okay, sorry for a marker. Du dx is equal to 5. Okay. Now from here, can we make u the subject and dx the subject? Yes. I can say du is equal to 5 dx. So by transposition of formula, I don't know, we are going to have what? Dx is equal to 1 over 5 du. I'm repeating. Here, I just swap this, and dx is equal to 1 over 5 du, or du over 5. So I'm going to put this in place of dx. What is the original expression? So over here, this is it. So I'm going to have something like this. Remember that we said here is what? U. Okay, here is u to the power 3. You remember? Then the x we have got is what? 1 over 5 du. So this one, the 1 over 5, will come out and becomes 1 over 5 integral u to the power 3 du. So how do we integrate this? So it becomes 1 over 5 u to the power 4, because we add 1 to it, over 4 plus c. So in effect, I'm going to get u4 over 20 plus c. And remember that our u is what? Where's our u? Our u is 2. So I'm going to have into bracket 2 plus 5x to the power 4 1 over 20. Then what? Or 1 over 20 is the same thing. 1 over 20. Sorry. 1 over 20 u to the power 4 plus c, where c is the integration constant. So that's what we have. I'm going to solve another one. Okay, let me just clear the board so that we solve a variety of them. Okay, that's what we've got. So I'm going to pick another one, then we solve. I hope you are making notes from what I've just explained. Okay, and try as much as possible and be working. Don't relax. Okay, always be working more. Example, try your hands on mathematics. It needs practicing. Mathematics needs practicing. So if you don't practice, you will not get it well. So try as much as possible, always to practice, and that will actually make it successful. That's why we have a lot of casualties in mathematics. It needs practicing. So please, we are on integration. Okay. Now I want us to look at a typical, another example, another integration. I've just captured. So let's look at this one also. So we have to evaluate integral 2x plus 1 to the power 4 dx. What do? This one, we let what? U be equal to what? 2x plus 1. Is that okay? Let this be what? 2x plus 1. So, du dx is equal to 2. What are we doing? We are trying to do something to get rid of this dx and rather become du. So by swapping it, if you work it out, you're going to get dx, this one go, this one comes, it becomes what? 1 over 2 du. This is your dx. So I'm going to replace this thing over there. So the original expression is now going to be what? Integral, and you know this is what u, so we have u to the power 4 here, because it said let u be equal to u to the power 4. Then instead of writing the x, we are going to write what? Half du, okay? Now, this half is a constant, so when you are doing integration, this half has to come out. Comes half integral u4 du. So if I integrate this, it becomes what? Half, the inside here becomes what? U4 plus, because U5 over 5, okay? Then plus what? Plus C. So in effect, I'm going to have U5, okay? 1 over 10 U5 plus C. And what is our U? You come back to here. So it becomes 1 over 10 into bracket 2x plus 1 to the power 5 plus C. Is that okay? That should be okay simply because you should be okay about it. Alright? Sure. You are still firing. This is Calendar Man TV. And the person who is teaching is called Calendar Man. You see, people are asking why Calendar Man? Calendar Man because I used to calculate date of birth for people on the television. When you mention your date of birth, I instantly tell you the day you were born on the TV, and your mind has to move forward. That's why now I'm dwelling more on the mathematics, moving forward. But my background is, I did mechanical engineering. I'm now doing, PhD. This is Sustainable Energy Engineering and Management at University of Energy and Natural Resources. That's what I'm doing. So that's it. I'm a product. I went to the KUSC. Okay, that's why I did the first and the second degrees and the Takrady Technical University. Also, St. Paul Technical School and these places. Okay, we are not boasting, but we are just saying to praise God that He has done very well. Okay, from where we were coming from, and I think I have to actually help the little that I have. Not that I'm too much, so powerful, but the little I have, I want the general public also to know. That's why I've created this TV channel to be able to, give people that information. Now, let's look at another one. We are talking variety of, we have another one which is what? They say we have to do 2x plus 1 to the power, this one we have solved it. We have solved. So let's see. Let's see other one. We have what? 3x plus 5 to the power 5. Okay? You say you have to what? Integrate dx. What did we say? Yes. What did we say? Here, we let what? We let you, this one, let it be what? 3x plus 5. Is that okay? If this is that, then we say that du dx is equal to 3. What are we doing? We want to replace this dx by du. So you just swap this and become du over 3. Then this one goes there. So finally, we got what? Dx is equal to what? 1 over 3 du. So now, wherever you see dx, we put this one there. So in the nutshell, you are going to get what? So we have what? U integral, because here is u, so integral 5. Then the dx is what? 1 over 3 du. So we bring the 1/3 out. Then this integral becomes what? U5 du. So we are now going to integrate this. So it's going to be what? 1 over 3 u5 plus 1 is equal to u6 over 6, okay, plus c. So I'm going to have u to the power 6 over 18 plus c over 18 plus what? Plus c, if I'm right. Okay. So if that is the situation. Now let me check something, whether I'm on track. Let me go back here and see whether everything is on course. Yes, I think it's on course. So here, moving forward, I'm going to have 1 over 18. Then the u is what? Into bracket 3x plus 5 plus c. This is that integral. Okay. Now, I want you to try this. But okay, this one, let's work it together because of some specific reason. I hope I can clean here. Okay. This is integration, that is calculate it to real 5. Here, have you seen there's 3 here, then x plus 1 to the power 5 dx. Don't let the this 3 scare you. So you let what? You let u be equal to what? X plus 1. So du dx is equal to 1 because when you yes, du dx is equal to that. Here you differentiate this, okay? Here, over here you differentiate, not integrate. You differentiate first. After that, then we say that the x is equal to what? Du. Okay, du times 1 is the same thing. So once again, what are you going to have? You are going to have this integral sign. This 3 will come out like this. Okay, then u d what? Du. And when you integrate this, what are you going to have? You are going to have 3 times. What is going to happen here? Already there's 1 here. 3 times u square over 2 plus c. So in effect, I think we're going to let's check if everything is all right over here. Because I'm trying to follow the steps to know if everything is all right. Where is the 5? Where from the 5? Oh, okay. Here is rather 5. I think here is rather 5, if I'm right. So if that place is 5, then here is going to be u6 over 6. Is that correct? u6 over 6. I'm trying to go over to see if everything is all right. So this one becomes what? 1 over 2 u6 plus c. So here you have 1 over 2, and you know u is what? U is what? U is x plus 1 to the power 6 plus c. Yes, I think that is it. Okay, that's it. Okay, so you can try your hands on. I'm writing this one for you. Try your hands on them and see if you'll be getting your answer. Try your hands on this one. Go and evaluate this one. 5 minus 2x to the power 3, which is I part. Then I integral 1 minus x to the power 3. Then I 4 s cubed minus 3x plus 2 dx. All these are what? Dx. Try your hands on them. Okay. Now, let's look at just one example under the definite integral. Definite integral. All these ones, they were not definite, but we don't know the limit unless they give you. So let's look at just one definite integral. They say you have to evaluate this. And we have 3 here, 2 here. Then it says here is 6x squared plus 2 plus 2, like this. Dx. We've been asked to evaluate this. Here, we are going to have what? We integrate this one, becomes what? 6x 3 over 3 plus 2x, okay? Now, instead of bringing plus c, you just do this. I'm repeating. You are integrating. After getting this one, instead of bringing what? But remember that here, we are going to have what? 2x cubed plus 2x. Is that okay? Instead of bringing, I say instead of what? Bringing the plus c. This time, you write here 3, you write here what? 2. What does that mean? It means what it means. So let's see. Let me come here. We are saying we have what? 2x cubed. 2x cubed plus 2x. 3, 2. The meaning of this is that we are going to rewrite this and it's going to be 2. Then whenever you see x, you put 3 there. So 3 cubed plus 2, you put what? 3. You close the bracket like that. Minus the same thing. This time, whenever you see x, you put 2 there. It comes to what? 2 to the power 3 plus 2, 2. Have you noticed the difference? You write this, then whenever you see x, you put what? You put 3 there in the first bracket. Everywhere you see x. And the second bracket minus, whenever you see x, you rather put what? You put 2 there. So in the final analysis, because of to save the time, I just wrote the figures here. Here becomes 2 times what? 27 plus 6 in this bracket. Minus, here is 2 times 8 is what? 16 plus 4. Here I'll give you 54 plus 6 is what? 60 minus 20. And the answer is what? It's 40. This is definite what? Integral, okay? Okay. So now, that's definite what? Integral. That's definite integral. So just follow it, I think with that one example. So try your hands on this one. Try your hands on this one. 4, 2. Then here is what? 5x4 plus 3x dx. Please try your hands on that one. Okay. I guess you finished copying this one, so we can clean it and move on. Okay. We want to look at integration of trig functions. Okay. Integration of what? Of trig functions. Sometimes fundamentally certain two the functions they are very, very important to us. That is when you differentiate, when you integrate what? Cos x, we get sin x. And when you integrate sin x, you get negative cos x. But it is the reverse way in the differentiation. By integration, this is what is happening. Exactly. So, why don't we quickly look at a typical example and follow it as such. So, they say we have to evaluate, let me see if I can get one. cos 2x dx. So over here, we let what? U be equal to what? 2x. Exactly. So if u is 2x, then du dx is equal to 2. Exactly. So the x is equal to 1 over 2 du. So here, in integrating it, I'm going to have this one is going to what? Cos u, because we say u is equal to that. Cos u times what? 1 over 2 du. That means we have maneuvered to take away the x and brought this one. So in place of this, we have put this one there. So that our half will go outside, and this integral sign comes. Cos u du. And we are saying that if we integrate cos, we get sine. So it becomes half sine u, okay, plus c, which is half sine, what is the u? 2x plus c. This is the result. Half sine 2x plus it. Is that okay? That's it. Okay. And it is here. Boom, correct. Okay. Now, I said that cos x mapped to what? Sin x. But sin x mapped to what? Negative cos x in terms of integration. Okay. We are on integration still. Please subscribe to Calendar Man TV, okay? That's the message I have for you. Just subscribe to that. We have worked. Let's do another one. They say evaluate sine 5x dx. As usual, what is the first step? Let u be equal to what? 5x. And du dx is equal to 5. When you reciprocate it, you have what? So the x is equal to what? 1 over 5 du. So coming back here, we are going to have what? Integral sine. We say let u, so sine u 1 over 5, okay, du. So let's put the 1 over 5. It becomes what? 1 over 5 integral sine u du. And I'm saying that if you integrate sine, you get negative cos. So it becomes 1 over 5 times negative cos u plus c. So in effect, I'm going to get what? Negative 1 over 5 cos u, okay, cos u plus c. And you know u, so negative 1 over 5 cos, what is the u? 5x plus c. That's it, okay? So, negative 1 over 5x plus c. We are still on integration, okay? Integration in calculus. Calculus 5 is what we are on now. Now, let's see another one. We are working more examples. I've told you that this platform is a problem-solving platform, and we have cos 3x plus 2 dx. What do you think we have to make the subject? We let what? We let u be equal to 3x plus 2. So du dx is equal to what? 3. Exactly. So the x is equal to 1 over 3 du. So coming back to this expression, I'm going to have this, okay? And we have what? Cos u 1 over 3 du. So I'm having 1 over 3, okay, 1 over 3, when you integrate cos, what do you get? When you integrate cos, you get sine, so sine u plus c, which will be equal to what? 1 over 3 sine, sine what? Because if you are integrating cos, you get sine. 1 over 3 sine u, which is what? 3x plus 2, then plus c. Okay. So this and many more. So you can continue to be trying and trying and trying. So let me see. I'm trying to get some of these. This one is a 1 up to 8, and I think my producer has to pause a little bit for me as I look. Okay, let's see another one. We are asked to evaluate 3 cos into bracket 4x minus pi over 2 dx. Once again, you do what? You let u be equal to what? 4x minus pi over 2. Note this, that the pi is a number, 3.142. Pi is a number, or 22 over 7. Note that it is what? A number, the pi. Pi, okay. So if I am to, so we have what? The u dx is equal to 4. This one is constant, it goes to 0. Okay. So what is the x? So the x got what? 1 over 4 du. I've set several examples for you to get it. So now, going back to the equation, I'm going to have what? Integral 3 cos u, okay, times 1 over 4 du. So I'm having 1 over 4 times 3. The 3 will also come out. Okay. Integral cos u du. This to the power 1. So here I'm having 3 over 4. Okay. 3 over, and what is the cos u? If you integrate cos, what do you get? You get sine. It becomes sine u. Sine u. Okay. If you integrate this one, what are we going to get? If you integrate cos u, you get sine u. Okay. So sine u. So what are we going to get? Now this is sine u plus what? C. So we have 3 over 4 sine. And what is the u? U is what? 4x minus pi over 2. Okay. Plus c. Let me check whether what I got it is that is 3 or 4, which is very, very correct. Okay. Now, so you can try your hand on this one. Try your hand on integral cos 2x minus 3 pi over 4. Try and evaluate that. Is that okay? Now, if you are done with this one, then I'm going to integration of exponential functions. Integration of what? Exponential functions. Exponential functions. Okay. I'm saying that integration of what? Integration of exponential functions. Now, A typical example is like this, where we have e 5x dx. It is a similar approach that we will be going about. So here once again we let what? We let u be equal to what? 5x. And du dx is equal to 5. Okay? So dx is equal to what? 1 over 5 du. Is that okay? So I'm going to put it there. And putting it there, I'm going to have integral e u 1 over 5 du. So I'm having 1 over 5 integral e u du. And you know that if I integrate this, I'll just integrate this and divide. So it will be the same. So it's equal to 1 over 5, okay? E what? EU plus C. So it will be what? 1 over 5 E. And what is our U? 5x plus C. Okay, that's it. Okay, that's the 12. And we have many of them. So what I'm going to do is that I'm going to give you some of them. Then you will try your hands. After that, you can compare your answers and know whether you are right or wrong. Okay. So I'm giving you this together with the answers. Try and see whether you will also be working to get it. One of them is this: 3e 6x dx. The answer is 1 over 2 e 6x plus c. Try your hand and see if you can. Okay, try your hand on it. Then okay. Yeah, on integration of exponential what? Functions. Let's quickly look at this one. If I have integral e 2x plus 3 dx, follow the same suit and work it. And once again here, the answer that you are going to get is going to be 1 over 2 e 2x plus 3, then plus c. This is what you will get. This is your answer. So know the answer and see if you'll be able to get same. Okay. Now, these are two. Please write it fast. This is the answer, and this one too. This is the answer. Work out the missing steps, and then let's see. Okay. Now, you want to see exponential functions not having e as base. There are certain exponential functions, they don't have e as base, as you always see. So I guess we finished writing this one. So let's see this one. If I have integral, okay, ax dx, then we are expected to get ax, okay, then function x lim a. Don't let it baffle your mind too much. Well, we want to see a typical example. For example, you want to look at this one, a2x dx. Over here, all that we are saying is that maintain this original, which is a2x. Then down here, Differentiate this exponent. And that will give you what? Differentiate this one. It will give you what? It will give you 2. Then lane base. And the base is what? The base is A. If you want to go by, I can take you through the official process and see whether you get the same. Okay. Let's see. Here you have what? Integral what? A to x. Okay. Dx. So you let. I'm trying to get it. Let u be equal to 2x. So du dx is equal to what? 2, and dx is equal to 1 over 2 du. So when I come here, it's going to be what? What are you going to get? I'm going to have integral au half du. So the half will come out, and integral au du. So over here, as we said earlier on, we are going to maintain this, and it's going to what? Au all over differential of this one, which is 1. So lane what? Lane A. Our half is still here. Then plus C. Okay. That is. Oh, yeah, that's it. So plus C plus the constant. Okay. So sorry, I think plus C is here. These are many more. So you can try your hands on many of them. Okay. So we're going to look at one of them and then possibly see if we can move to the last aspect, which is we are on integration. Okay, let's see this one. You say we have to evaluate this. We have 4a 2x plus 1 dx. So what do you do? We let what? U be equal to what? 2x plus 1. So du dx is equal to 2, right? So over here, what is dx? Dx is equal to 1 over 2 du. So I'm having integral 4. What happens? 4 a u. That's 1 over 2 du. Okay. So I'll pull the 4 and the 2 out, and becomes what? Integral au du. And as we said, so we have what? Here becomes what? 2, then au all over, to differentiate this, all over what? All over lane A, then plus C. So we have 2a, and what is the u? U is what? 2x plus 1 all over lane A. Okay. Then plus C. I think that this and many more. So you can try your hand on others. So this is where we are, and then for the tutorial 5. Okay. So I've already informed you about Forever Construction and Consultancies Limited. I just put their information on a piece which I wanted to actually get. But what I'm saying is that if you want a piece of land, then the best place that you have to go is the Forever Construction and Consultancies Limited. Yeah, so as I've said, just go through what we have just done, and I'm going to be practicing, and it will be okay. Please, I'm just urging you to subscribe to Calendarman TV, okay, for more updates. We have a lot that we're going to cover, a lot of topics that you wouldn't even in classroom, your actual classroom where you are schooling, you may not be getting it that way, but I'm saying that try as much as possible, and then subscribe, okay. When you subscribe, make sure that you press the notification button. So I think we'll be treating matrices, we'll be treating trigonometry, treating plane geometry, which has been worrying students a lot, and others. Even the calculus, and then the matrices, that we shall be going further. Integration by part and other, but not now. For now, you'll be moving to different topics, after the lecture 6. Well, the lecture 6, I think we'll be talking about separating variables and other than you'll be earning. Thank you very much, and stay tuned for calculus tutorial 6, which is integration tutorial. So thank you.